Hello everyone. F of x is given in terms of x and 1 over x, and then find minimum and maximum of f of x. In order to find minimum and maximum of f of x, we need to find the extremum points of this function, and from the extremum points you can find out the minimum and maximum of f of x. But before carrying on to solving this problem, I just wanted to establish a couple of relation. The first one is sum of the squares, sum of the squared of two numbers like a and b. If we have a squared plus b squared, this can be written in terms of a and b as such: a plus b quantity squared minus 2a times b. So this is relation 1, and relation 2 is gonna be the chain rule in derivative, in derivation basically. So if we have a function f of y where y is a function of x itself, the derivative of f with respect to x will be y prime times f prime of y, where y prime is d of y over d of x, and f prime is a derivative of f evaluated at y. So let's call this as relation 2. Let's carry on and simplify f of x in terms of a simpler value or parameter basically. If we consider that y is x squared plus 1 over x squared, this is kind of a more straightforward function where x squared plus 1 over x squared is positive. We know the we can evaluate the behavior of y when x goes to 0 or infinity. And let's rewrite f of x in terms of y if we can. So f of x will be equal to, on the numerator, x plus 1 over x to the power of 4 can be written x plus 1 over x squared minus, let's use relation 1 to write x to the power of 4 plus 1 over x to the power of 4 in terms of y. It's going to be x squared plus 1 over x squared quantity squared minus 2 times the multiplication of x squared and 1 over x squared, which is going to be 2, minus 1. And then on the denominator, let's expand this value. It's going to be x squared plus 1 over x squared plus 2 plus, and then rewrite this one, which is y itself. X squared plus 1 over x squared. Let's simplify these relations and rewrite everything in terms of y basically. So let's expand this. This is going to be x squared plus 1 over x squared, which is y, plus 2 squared minus y squared. We'll have y squared minus 2, which is plus 2, minus 1 is going to be plus 1. And on the denominator, we'll have y plus 2 plus y. So if we further simplify this one, we can expand the y plus 2 quantity to the squared, and we'll have y squared plus 4y plus 4. Y squared will cancel out with y squared. We'll have 4y plus 4 plus 1, which is going to be 5, over 2y plus 2. So f of x or f of y will be 4y plus 5 over 2y plus 2. Let's further simplify this one. We can write this as 4y plus 4 plus 1 over 2y plus 2. 4y plus 4 over 2y plus 2 is 2, plus 1 over 2y plus 2. So from here, we can see that since y is always a positive value, and if x goes to 0 from left or right, doesn't matter because x squared and 1 over x squared are both positive, then y will go to positive infinity. Right? So because this is 0, and this x squared is in the denominator, as x goes to 0, this goes to very large values, and hence y will go to plus infinity. So from here, if y goes to infinity as a result of x going to 0, then this value will go to 0, and then f of y is always more than 2. And from here, minimum of f of y, a global minimum of f of y, is always 2. So f of y is always more than 2. It might not be equal to 2, but minimum of f of y is always gonna be 2, or f of y will be always more than 2. Let's carry on with finding the extremum points of f of x. So we came to a conclusion that f of y is 2 plus 1 over 2y plus 2. Let's take the derivative of f of y. So f prime of y, and prime is with respect to x, will be derivative of 2 plus 1 over 2y plus 2. Derivative of 2 is 0, and derivative of 1 over 2y plus 2 will be minus 2y prime. Basically is negative of the derivative of denominator over denominator plus squared, basically 2y plus 2 squared. If we take this, if we put this equal to 0, then from here y prime is equal to 0. So y prime will be, so y is x squared plus 1 over x squared. Y prime is gonna be equal to 2x minus 2 over x cubed. Right? If we put this equal to 0, x cannot be 0, and then we multiply both sides with x cubed, we'll have 2x to the power of 4 minus 2 is equal to 0. From here, x to the power of 4 is equal to 1, and then x of extremum will be plus and minus 1. So we'll have two extremum points which are plus and minus 1. Let's evaluate function f at this point. So we'll have, if x is plus 1, then f of 1 will be equal to 1 plus 1 to the power of 4 minus 1 plus 1 minus 1, 1 plus 1 squared plus 1 plus 1, which is going to be 16 minus 3. It's going to be 13 over 4 plus 2 is 6. So one of the maximum points, max 1, let's say, is gonna be 1 and 13 over 6. And if x is negative 1, then f of negative 1 will be negative 1 to the power of 4 minus 1 plus 1. So basically I am plugging minus 1 into this equation. Minus 1 to the squared plus 1 plus 1. This is again 13 over 6. So maximum point 2 will be negative 1 and 13 over 6. And minimum, or a global minimum of f of x is basically 2. At x0, basically, like 0 and 2. Thank you very much for watching.